Ciao friends! In this video we are going to see the context transition described in a visual way. Yes, in previous articles and videos I shown you the filter context and then the row context explained with the support of some visual representation. We will do the same today for the context transition. As usual, these videos do not replace more complete description of these concepts. See them as an additional element, as a different point of view to better understand and to better have an idea about these fundamental concepts of the DAX language. Let's start with the demo. The definition of the context transition, the formal definition, is simple. The context transition transforms any active row context into corresponding filters in the filter context. Now, this definition hides a number of details and sometimes complexities that we are going to try to simplify by using a visual representation. But first of all, what triggers, what generates a context transition? Well, the context transition is generated when you have a function like calculate and calculate table, or when you have a DAX function that internally invokes one of those two functions, calculate and calculate table, or when you have a measure reference, because the measure reference implies calculate. Now, how do we know which functions internally use calculate and calculate table and produce a context transition? Once again, with DAX guide, we can filter only those functions that have a context transition. We are highlighting those functions now, and if we just select this button, we filter them. And you can discover that beside calculate and calculate table, pretty much all the time intelligence functions have a context transition involved. So if you want to see more details about that, take a look at the description of each of those functions on DAX guide. You will see the corresponding function in DAX and why there is a context transition. Now, the context transition is relevant only when you use one of those functions when you have a row context. And our goal today is to understand what happens when there is an evaluation that involves the context transition. In most of the examples, I will just use a measure reference because the measure reference internally has a calculate statement that generates the context transition. So we're going to see how this works. And we start this analysis by looking at a report that I prepared where we have a report that has the measure sales amount. There is no context transition involved in the calculation of sales amount, internally to sales amount. And then we have the average customer sales. Basically, we're saying for each brand, we want to know what is the average amount of sales to a single customer for that brand, considering the customer that have at least one purchase for that brand. The implementation of this calculation has been made with a very simple DAX calculation. We iterate the customer table with average X, the customer table in the current filter context, but we're not filtering customers, so we are iterating the entire customer table in this case. And for each customer, we compute the sales amount. If the customer doesn't have sales, the result will be blank and it will be ignored by average X. Average X will compute the average only of those customers that have one value returned by sales amount. That's the idea. But how does it work? So let's see with the whiteboard, let's describe step by step what is happening in the evaluation of this calculation. So first of all, we have, you see in the corner here, we have the average X customer sales amount that I shown you in Power BI Desktop. The customer table reference is actually referencing the customer table. So customer is a table reference and shows all the rows from the customer table in the model that are visible through the filter context. Now, there is no impact in the filter context here because the customer has all the customers, but if we had, for example, a slicer for a country, we would have received only those customers in that country. Now, because average S is an iterator, the table customer is then iterated row by row. So the table customer is generating the row context for each row. So for the first row, we have a row context. For the second row, we have a row context, and so on for all the rows. So this is the iteration in place. Now, for each row, and so for each row context, we have a context transition. The context transition is this step that is triggered by the presence of the measure reference. And the measure reference is triggering this behavior, context transition, which basically moves the row context into the filter context. If we represent the row context with a table that has just one row, as we have seen in previous videos, well, actually this table is simply applied to the filter context. And because the filter context already included a filter, for example, if we consider the cell for Contoso, we have a filter context that filters one brand. And so this is the filter that exists, and the row context is added to the existing filter. And because it is added to the existing filter, what we get at the end, we get a number here, let's say 1, 2, 3, which is the result of the sales amount measure in this filter context. So this final filter context we obtain from the context transition, which is the existing filter context plus the new filter provided by the context transition, is where we obtain the number for the first row. Guess what? This is a process that is repeated for every row. And for every row, the context transition creates a new filter context, evaluates the measure in that filter context, and so on. So we have another number here, we have another number here, and at the end, this is what happens during an iteration. And during an iteration, this is the execution row by row. Depending on the iterator that you're using, the final aggregation is applied to this list of numbers that has been obtained. Because we have average X, right? We have average X here. What we do at the end, what the engine does at the end, we don't do anything, but the engine does an average of the numbers that have been obtained row by row this way. If we use SumX, we would have obtained the sum and so on for every iterator. But the principle is that this behavior, the context transition behavior, doesn't change depending on the iterator. The iterator only changes what is the result obtained by using the list of values that have been produced by iterating the table in the iterator. So this is how the calculation of the sales amount works, of the average customer sales work for this report. Now, when we add a filter to the filter context, of course, we have side effects. What happens if that filter already exists, or what happens if we want to remove some filter? So, in other words, we might have the need of manipulating the filter context obtained after the context transition. Let's see an example here. We have a measure, sales top customers, where we want to obtain the result of the sales only for those customers that have, for that specific brand we have in each row, at least 1% of the total of the sales for that brand. The brand or the category or the color, it doesn't matter. So the idea is that in the report, considering the value visible for all the customers, we want to get only those customers where each customer has at least 1% of sales, 1% of sales of the total sales for that particular row in the report. For example, here, if we look at this report, we see that for Contoso, the result is blank. We don't have any customer that has at least 1% of the total of sales amount for Contoso. But when you look at Datum, a Datum or AdventureWorks, well, it's a small number, but there are a few customers that have at least 1% of the total. So how do we implement this calculation? Well, if we take a look at the definition of sales top customer, sales top customers has to do the following. We have to compare customer by customer the sales amount of the customer with the sales amount of all the customers. Now, for educational purposes, we try to do this calculation row by row. We will see at the end that there is a more optimal way to obtain the same result, but I wanted to introduce with a simple example, without introducing a too complex algorithm, how to manipulate the filter context after the context transition. So we're looking at that non-ideal DAX code because we want to understand how it works, how we can manipulate the filter context. And so what we do in order to obtain this result, we compute the value of the current customer in the current filter context with the context transition. So this sales amount will produce the value for the current customer, and this sales of customer will produce the value for all the customers. But because there is a calculate statement that performs a context transition, we want to remove that context transition. So how can we do that? Because if you think about the problem, when we write the first row here, the first expression, sales amount is computing the sales amount with the context transition, transforming the current customer into a filter. So how can we get rid of the row context or get rid of the filter context obtained from the context transition if we have to? That's the problem we are trying to solve in the second step of the calculation, and then we compare the two numbers to decide whether we want to include or not the value that we obtained. Now, let's move to the whiteboard, because at this point I want to show you this calculation step by step, so that we introduce now a description, a visual description of what is happening in the several steps and how we can manipulate the filter context when we need to. So first of all, if we look, let me just enlarge this a little bit. So if we look at the definition of the calculation, we have two elements. We have this first part of the calculation where we compute the sales amount for each customer. So when we iterate customer, as we learned before, so the customer table that we are iterating row by row produces a row context. Now we are simplifying the row context by using only 3 columns of the customer table. So for one row that has the customer Bob, what happens? Well, by applying the context transition, so when we have sales amount, the sales amount applies the context transition and moves this row context into the filter, what we get is the filter context, the new filter context that inherits the existing filter context we had in the cell. For example, the highlighted cell is Fabricam, and in this filter context, we extend this filter context, getting both the original filter context plus the new filter. Now, what we want to do, we want to compare the value for that customer with the value for all the customers. Now, how do we get the value for all the customers? Well, if we have this context transition already executed, what we really want to do, we want to get only the brand. We want to retrieve the original filter context. So if we look at the second step, what we have is the following. So this time, we still have a row context that is transformed into a context transition. But what triggers this context transition? The first calculate that is executed in a row context is what triggers the context transition. So now the context transition happens not because of the measure reference, but because of our calculate. And so this is the first operation that happens. So this row context becomes part of the filter context. And at this point, because the filter is now there, we can remove that filter. And so if we use this other function here, remove filters here, so this remove filters is actually saying, well, I want to remove the filter from the customer table. And so this filter is removed. Because the context transition happens before any filter modifier of calculate is evaluated. And the filter modifiers are evaluated before the additional filters are applied to the filter context. But the important element is that the context transition happens before the filter modifiers. And so the idea is that if I trigger the context transition before the evaluation of sales amount, now I already consume the context transition. I remove the effect of the context transition by removing the filter from the customer table, like I did in this line that I highlight now. So this line is removing the filter from customer, so it's removing the filter that has been obtained with the context transition, and now I have the same filter context I had at the beginning, just the brand, all the customers. Now, this example was for educational reasons, because if I go back to the Power BI example, I can show you a different way to implement the same calculation, which is much simpler. I can simply say, well, I want to get the sales of customers before the iterator. Why should I get rid of a filter obtained by the context transition when I could obtain the same number just before saving the number in a variable before starting the iterator? Because in that point, I have exactly the filter context I need. But again, this is just because I want to make sure that you understand that this was an example for educational purposes. There could be more complex calculations and iterators where you want to obtain that result. We want to remove the raw context from the result of the context transition because you don't have the alternative to get the right value before the iterator. So it depends. There could be cases. It's important to understand how you can manipulate the filter context, removing the effect of the context transition. But there could be another case. There could be a case where we want to apply the filter to the filter context without removing an existing filter. Because yes, when you apply a filter to the filter context, by default, the existing filters for the same columns are removed. And we know that keep filters is a function to keep the existing filter, but there is only one problem. Keep filters in calculate requires to be applied around the filter that we apply, but the context transition does not have an explicit filter in calculate, so how do we manage that? We're going to see that, but before, let's start looking at the problem that triggers the need for that. Of course, we have to introduce a more complex example because usually these problems happens when you have complex filters in the filter context. In this case, we have a report where we filtered only 4 months, 2 months from 2018 and 2 months from 2019. We have a column year and a column month in the date table that we are using in this report. So far, so good. Now, the problem is that we want to compute in a measure the average, the monthly average, which if you look at the numbers here are correct. So this number is the average between these two numbers. This number is the average between these two numbers. So for each year, the number is correct. There is one big issue here. This number is absolutely incorrect. It's not possible that the average of 4 months is greater than the largest value that we have in a single month like this one. So there is something really, really wrong going on. So let's try to understand what is happening and then how, of course, we can obtain the right number by writing the measure the right way. But let's see why we are producing this incorrect number. What is the implementation we used to get that number? So let me just enlarge here. So we start from the incorrect version. So the incorrect version is a relatively simple calculation. We want to iterate by month, and for each month we compute the sales amount. And let's see what is happening in this case, again, with the help of the whiteboard. So first of all, let's start with a simple consideration. The number that has a problem is just the total, the line with the total. And that line has a filter context that includes 4 combination of year and month. Now, if you paid attention, we have 2 columns involved. We have year, we have month. And so the filter must combine values that have year and month, because we only want those specific combinations of year and month. 2 different filters with year and month in an independent way will just produce all the possible combination, which are 8 combination between 2 years and 4 months. But no, we want only 2 months of one year and 2 months of the other year. So this is the way to go. Yes, I know. If we used a column that had both year and month, it would have been simpler. But again, for educational purposes, we're going to see what happens when we don't have that situation and we have to combine 2 different columns in a more complex filter. So in this filter context, what happens? Well, our calculation performs an iteration over the unique values of the 8 month. Now, the table that we obtain for this year this date month column, so distinct date month, produces 4 rows. Remember, we're iterating only one column, which is just the month. And this produces just 4 rows, and for each row we have a row context. And the row context has only one row, one column. 4 times we have this row and column. Now the context transition triggered by the measure reference, so this context transition moves the row context into corresponding filter in the filter context. But at this point, what happens? Well, at this point, we have the regular behavior of the filter context. If I filter month, this triggers the removal of any filter over the same column. So because we are filtering month, this is going to remove the filter from the month column only. Not from the entire filter, but just on the month column. Which means that now, what do we have? Well, now we have a filter for month, 1 month, and a filter for year, and we have just 2 unique years, 2018 and 2019. So in other words, if we look at the result of the filter context, we have, let's see, we have this. So the result of this filter context, if we simplify this filter context, we obtain this. We obtain 1 month and 2 unique years, even though we see 4 values, because we see here, we see here the 4 values, 2018 twice and 2019 twice. But what happens is that only the unique values matter for the filter context. So actually we are filtering 2 years and 1 month, which explains why the number is wrong. Because if you think about this is repeated for every month. So every month, so for October, we are getting the sum of 2 years, October in 2 years. We will do the same for November, for January, and for February, which means that if I prepared a simple example in Power BI Desktop to show you the numbers that we are computing. So we are doing the average here, but we're doing the average of these 4 numbers, where, because we selected 4 months, we're getting the sum in each month of the 2 years, because this is the result that we obtained in the previous filter context. Why did this happen? Well, this happened because month removed the filter over the month column, but actually this is a case where we didn't want to remove the existing filter. We want to just keep the existing filters. But again, it's a problem of the syntax. So, okay, we want to, let's go back to the whiteboard. We basically want to stop this. We want to stop this to happen. We need to stop this filter removal, because if we don't have that, we have the right filter context. We have 4 combinations of year, month, and 1 month only. So we will see only October in the right year by combining the 2 filters together. So the solution is key filters, but key filters must be written, and I show you in Power BI Desktop first. Key filters must be written by using the iterator. So let's see the monthly average correct here. So this is the technique. We cannot write key filter inside calculate, because if we write calculate, the context transition already happened. If we need to keep the existing filter for the context transition, key filters must be applied to the iterator. So when you see key filters before an iterator, you have to think key filter will have an effect in the following context transition, in this case sales amount. Okay, so this is the technique that we have to use, key filters around the iterator. Let's go back to the whiteboard to see how this works step by step. So I think I prepared this here. Here we go. So we have the only difference with the previous calculations that now we have this key filter. So let's repeat the several steps. So distinct month produces a table that has 4 rows. Then we have for each row, we have the row context. So let's consider the first one, maybe with the right color, orange. So let's go back here and let's use the right color here. We have the row context, then we have the context transition produced by the measure reference, and the measure reference moves the current row context into the filter context. And one important element is that at this point, we would expect this to happen, right? We would expect this filter to propagate. But what is helping us is the presence of keep filters. So these keep filters here is creating like a protection that stops the filter, the removal of the filter propagated to the existing filter. So in other words, it's a shield that protects the existing filters for the context transition only. So that keep filter has only an effect for the context transition. So this way, if we go back to Power BI Desktop, this way, let's see if I can see the right, okay. This way we obtain the right number, which is this one. So this is the number that we obtain with the calculation that has keep filters, because the presence of the keep filters does not break the existing filter, preserve the existing filters, and in this case produces the right result. Once again, most of the times you don't need this technique because you have filters on a single column only, and this pretty much affects mainly cases where you have complex filters with 2 or more columns. But in general, whenever you have to preserve the existing filter, keep filters must be used around the iterator. And now you have a visual representation of all these situations. So we have seen that the context transition is something that can be explained in a graphical way. The context transition transforms any existing row context into a corresponding filter context. And when we already have a representation of the row context as a table that has all the columns in just one row, it's very easy to translate this concept into the filter context, into a filter of the filter context. Of course, we have to be able to manipulate the filter context after the context transition by removing the effect of the context transition, or by not removing, by keeping existing filters in case this will conflict with the new filter provided by the context transition. I hope that this will help you to get a different perspective about these important concepts of the DAX language, but as usual, enjoy DAX!